So today we're going to talk about parallel lines, and parallel lines have the same slope. So if I'm looking at the red and the blue line, I can see that they may appear that they're never going to touch, but I can only determine that based on the fact that I can look at their slopes. So in this case, I'm just going to pick 2 points on the blue line, and I know that it goes down 1, right 2. So the slope of this line is -1/2. Now, for these two lines to be parallel, I need to know that the other red line has the same slope. So again, I'll pick 2 points, and then from there, see if they have the same slope. Again, down 1, right 2, so the red line has a slope of -1/2. In this case, because I know they have the same slope, I can determine that they're parallel. But just by looking at the graph, I can't decide whether they're parallel or not. I need to know their slopes. So the rule is parallel lines have the same slope. In the next examples, we're going to look at some equations to determine whether or not these lines are parallel. So take a look at these 3 lines and determine whether or not they are parallel. So in the first example, we have an equation that's already in slope-intercept form. So with that, we can identify that the slope of this line is 2. In the next line, I have an equation, but it's not in slope-intercept form. So the first thing I need to do is to change it into slope-intercept form by subtracting 2x from both sides. Once I do that, I'll be able to get 3y by itself, and then from there, I have an equation that I can divide by 3. So y equals 2x plus 6 on this side, only now I have to divide everything by 3. When I do that, these cancel out, and I'm left with y equals, and then on the other side of the equal sign, I need to take a look at the slope. In this case, the slope is -2/3. The x comes down with the 2, and now I have 6 divided by 3, which is +2. So my equation is y equals 2/3 x plus 2, and my slope is the coefficient of x when it's in slope-intercept form, so my slope is 2/3. These two are not parallel because they don't have the same slope. Now let's take a look over here. In the third example, we have an equation that says 4y equals 2x plus 4. If you look at this very quickly, you would notice that the 2x would indicate that they may be parallel. However, because the coefficient of y isn't 1, we didn't solve completely and put it in slope-intercept form. So we really do want to divide everything in the equation by 4. And when we do that, the 4's cancel out, leaving me with just y. I also have the fraction of 2/4, which can also simplify to 1/2, and then we have the x. 4 divided by 4 is 1. So my equation of y equals 1/2 x plus 1 would not be parallel to y equals 2x plus 4. None of the equations are parallel because none of them have the same slope. Now let's take a look at an example of actually having to write an equation of a line given some information. And the first piece is that we have to write the equation of a line that's parallel to this equation. It also passes through this point. So going back to the original graph, we see that there are 2 parallel lines and they pass through different points. So for instance, if I wanted to write an equation of a line that passed through this point, but it was also parallel to the red line, I would need to know some information. What's the slope? What's the point it's passing through? And so in this case, we have a line with the slope in slope-intercept form. We also have a point. So without having to graph it, I'm going to use some information that I already know, and that is the equation y equals mx plus b. Once I have the equation, I know that I can substitute some information in. For instance, slopes of parallel lines are equal, so therefore I know the slope in the original line is 3. So I can plug in, for my m, I can also plug in 3. Now, in this equation, I have a y, an x, and a b, and the other information that I have is this point right here. This point has an x coordinate, a y coordinate, and conveniently I have an x and a y variable that I could substitute in. So for the x, I'm going to substitute -6, and for the y coordinate, I'm going to substitute 5. The only variable I don't have left is my b, which I need to solve for. So I need to multiply 3 times 6 to get negative 18, and then I have an equation that I can solve using an inverse operation by adding 18 to both sides. 5 plus 18 gives me my b value of 23. So my equation of a line parallel to y equals 3x minus 9, but also passing through this point, is y equals the slope, which is the original slope of 3, and my new b, which is 23. This is my final answer for the equation of a line parallel to 3x minus 9, but also passing through this point here. The next topic we're going to talk about is perpendicular lines. Perpendicular lines have slopes that are opposite reciprocals of each other. And what I mean by that is that if I pick a point, any point, let's start with the one where they intersect. The red line has a slope from here of going up 1, right 2. So the slope of this line is 1/2. Taking a look at the blue line, starting at the same point, I'm going to pick this point as well as another point right here. This slope is -2, 1. So the final slope would be -2/1. If I write those, you can see how positive 1/2 and -2/1 are reciprocals of each other, but they're also opposites. 2/1 is negative, 1/2 is positive. And so therefore, these two slopes are perpendicular. If the slopes are opposite and reciprocals, the slopes are perpendicular, and therefore you have a right angle created by those two lines. Let's take a look at another example. Here are two equations, y equals 2x minus 1 and x plus 2y equals 6. Let's take a look and see if they are perpendicular. This equation is already in slope-intercept form. I identify the slope of this line as positive 2. So if I write that as a fraction, it'd be 2/1. This equation here I need to change into slope-intercept form. So I'm going to subtract x from both sides, and that's going to get my y variable by itself. Once I do that, I see I have 2y equals negative x plus 6. Once I divide everything by 2, I'll find that I have an equation in slope-intercept form. The equation would be y equals, now I have a negative, but remember, there is an invisible 1 in front of the x. So it's going to be -1/2, and it's going to be plus 3, 6 divided by 2. The slope of this line, forgot the x, the slope of this line is -1/2. If I bring that over and compare it to the other equation, -1/2 and 2/1, are they opposites and are they reciprocals? 2/1, 1/2, and one of them's negative. These equations would be perpendicular lines. So yes, they are perpendicular. Let's take a look at the example of how to write the equation of a perpendicular line, very similar to the parallel one. In this example, we have a perpendicular line. There's the original. The slope is 4. So 4/1 is my original slope. I need something perpendicular to that. So first I need the reciprocal, which would be 1/4, and I need it to be opposite, so it has to be negative. In my equation y equals mx plus b, I'm going to need to substitute in -1/4 in for m. I also have my points of 8 and 2, so I'm going to plug those in for y and x. 2 goes for y because it's the y coordinate, 8 goes for x because it's the x coordinate, and you're going to solve for b. Here we have 8, but it's actually, don't forget, it's 8/1. So in reality, this is 8 times 1 over 4 times 1, and when we do that, essentially what it is 8 divided by 4, but don't forget -2. When I add that to +2 to both sides, I'm going to get a new b of 4. My equation of the line with a perpendicular slope of -1/4 is going to be y equals -1/4 x plus 4.